Frame analysis. Video 6. Analysis results. The loads for the steel frame are now specified and we can perform an analysis. We select Calculate and can then choose whether we want to calculate also in accordance with second order theory or not. This choice will determine how a possible design in the frame's plane will be carried out with respect to second order section forces or with respect to user-defined backing length. We choose here to calculate also according to second order theory. One can also choose whether to calculate all load cases or not. As a second order calculation is an iterative process, one can control the convergence condition and the number of iterations. The default values that apply are so selected that one do not normally need to adjust these. When the analysis is complete, the program jumps to the program part Results and displays the moment distribution for the frame with respect to the scale shown down to the right. The results shown are for the active load case. By default, results are displayed for second order, and with buttons 1 and 2, one can alternate between first and second order results. If both are activated, two curves according to second and first theory are displayed. Alternatively, the results for all load cases can be shown simultaneously. If one wants the maximum values to be displayed numerically, for example for load case ULS, according to second order theory, this can be done by choosing Options, Display Max Values. With the tools to the left, also shear forces, axial forces, and deflections can be shown graphically. With the plus and minus buttons, the scale can be changed to clarify the results. For a large complex structure, such a graph could perhaps be difficult to interpret, while it is possible to also look at individual members. If one double-click, for example, on member 9, a window just showing the result for that member is displayed, and the first order moments distribution is shown. Under Option, one can then also get second order results. With a measure stick, values at arbitrary points can be obtained. Maximum span moment according to second order for load case ULS is 161 kN and is situated about 3 meters from the left end. And the moment 0 point is situated about 5.7 meters from the left end. We can of course also choose to study shear forces or axial forces graphically, or tables showing forces, stresses, or deflections. It's of course possible to open the number of windows that is required. If one wants to study the results numerically instead, there are tables for the distribution of joint forces, joint displacements, support reactions, possible spring forces, and max and min tables for each member for one selected load case or all load cases in terms of moment, shear forces, axial forces, and stresses. Finally, one can also make an equilibrium check to verify that the applied loads and reactions match, namely that the solution is correct. The next step is now to design the frame according to the Euro